Hello student, today I am going to teach you counting sort algorithm. Counting sort algorithm is a linear time running sorting algorithm. This sorting technique has a concept which is very different from the rest of the technique that we have discussed today. I am going to give you the basic concept of the counting sort algorithm, and after that I shall give an example to explain it further. Okay, first of all, this is the algorithm of the counting sort algorithm. So I shall go through the algorithm with the help of this algorithm. In this algorithm, what we do, suppose there is an array in which there are data which we have to sort, and this data lies in the range from 0 to k. Suppose there are number, suppose I am sorting now 1 2 1 2 3 1. Here I have repeated the number 1 2 1 2 3 1. So here the number, there are three distinct number 1 2 and 3. So the number range lies between 1 and 3. So here what we do, we construct here this number of distinct number in the given data set is represented by a variable k. So what we do here for in the for loop for I equals to 0 to k, means for value I is equal to 0 to the number of distinct element, we initialize an array ci with value 0. Suppose in the given example, as I have taken example 1 2 1 2 3 1, here that I have to sort this number, finally this will be sorted as 1 2 1 2 3 1. So there are 3 ones, 2 twos and 1 3. So in we shall initialize an array of which length will be equals to 0 to 3, 0 1 2 3. Since there are three distinct number, maximum number is 3, so we shall construct an array C with length equals to k and initialize its value, each value with 0. After that we shall start a for loop for j equals to 1 to the length of the a and do Caj up to Caj plus 1. Actually initially the data that we have to sort is represented by the a, that is the array a, and a is the actual array that we have to sort, and c is the frequency array that represent the frequency of each distinct element. And initially, since there are k number of distinct element, so there is a c array with k distinct blocks and each will have value 0. After that, when we travel through the array a, which is the which have the data that you have to sort, is, and then we count Caj equals to Caj plus 1. It means we count the individual frequency of every distinct element. As after this step, Caj array, there will be 3 under 0, there is no 0. So in under 0 C array there will be 0 frequency. For 1 there are frequency is 3. For there are 2 twos, so the frequency of 2 is equals to 2, and for 3 the frequency is equals to 1, so the frequency will be equals to 1. And now for contains the element, now this is called the frequency array. You can say that the C is the frequency array which represents the frequency of the each distinct element. After that we again start a for loop for I is equals to 1, and here what we do, Ci equals to Ci plus Ci minus 1. Here we are counting the cumulative frequency. Cumulative frequency means if we are counting the frequency of 0, then after we are counting the frequency of 0 comma 1, or then after 0 comma 1 comma 2, and then counting the 0 comma 1 comma 2 comma 3, means we are adding on the previous frequencies with the current frequencies. So after that we will get the cumulative frequency. This is the main point with help of which the counting sort works. First it create a frequency table for each distinct element. After that it counts the cumulative frequency of each element, and now the Ci contains the number of element less than or equal to I. It means the cumulative frequency represent that these that much number are less than that number or equal to that number. After that what we do, for j equals to length a down to 1, we create an array b which will finally sort the data, and this is filled with these formula BCAJ equals to AJ and CAJ equals to CAJ minus 1. Every time we fill B is the final sorted array, A is the initially unsorted array, C is the frequency array, and after that finally B is the array in which we get the final sorted data. So you may not get the idea simply by looking at the algorithm. So I am going to give you an example with which it will be very clear to you that how counting sort works. So I am rubbing this page, and later on I shall discuss what the complexity of the counting sort. It is very simple technique, and it runs in linear time, means own time. But after I give you an example, you will be clear about. So crucial step here are array initialization of frequency array. After that you count the frequency of individual distinct array elements. After that you calculate the cumulative frequency, and finally you create a B, finally fill the B array with the formula BCAJ tends to EAJ and CAJ equals to CAJ minus 1. So I'm going to rub this page and I'm going to take an example. Let's take the same example. One, two, 1, 2, 3, 1. This is the initial array. Okay. In the first line of the algorithm, we have initialized an array of length k, which represented by the C. We initialize the array C with, here there are 3 distinct elements 1, 2 and 3, but we shall initialize an array of length 4 since array is initialized with length from 0 to k. There are 3 distinct elements, but we will create an array C with element 0, 1, 2, 3, and initially the value of Ci will remain equals to 0, because initially we will assume that we have just initialized the frequency array. We have yet not counted the frequency of each distinct element. So initially the value of each Ci would be equals to 0, and after that we shall calculate the frequency of each distinct element. How will we calculate the frequency of each element? The formula is CAJ is equals to CAJ plus 1. The formula was CAJ equals to CAJ plus 1, and we shall calculate this value from 0 to the length of the array. So for this array will be also indexed as 0, 1, 2, 3, 4, 5. So J is the value of the index of unsorted array A. So for J equals to 0, A equals to 0, C A 0 is equals to AJ 0. CAJ 0, initially the value is equals to 0 plus 1. So A0 is equals to 1. So C1 is equals to 1. Since you may simply check that first element is 1, so C1 is become equals to 1. We have the first element that occurred in the unsorted array A is 1, so C1 is equals to 1. So we shall place one value here. So we shall place a value 1 here. Okay, right? Now the next value CA2. Similarly, just we shall now for J equals to 1. Similarly, for J equals to 2, CA2 is equals to CA2 plus 1. Since CA2 is equals to 0 is equal to 0 plus 1 is equal to 1. So second element is 2. So C2 is equals to CA2 is equals to C2. So C2 is equals to 1. This will become 1, right? The next element is again 1. for j equals to 3. Now for j equals to 3, I am just rubbing this value 1 instead of 1. In place of 1, I am writing 3. So here what will happen? CA3 is equal to CA3 plus 1. Now CA2 CA2 j, this was j equal to 0, j equals to 1, this is j equal to 2, right? After 0 and 1, next number will be 2. Instead of that, I have written third 3 there. So this is 2. Okay. So A2 is equals to 1. So C1, A2 is equal to C1 would be equals to C1 plus 1. Means C1 is equals to 1. C1 is equals to 1 plus 1, because when j was 0, the C1 value became 1. Now the initial value C1 value was 1. Now 1 plus 1, this will become equals to 2. This will become equals to 2. Now for j equals to 3, for j equals to 3, CA3 is equals to CA3 plus 1. So CA3, A3 is equals to 2, means C2 plus 1. The value of C2 is equals to 1. So this will be 1 plus 1 equals to 2. So again the value of 2 would become equals to 2, right? Now for j equals to 4, I am rubbing this. For j equals to 4, for j equals to 4, CA4 is equals to CA4 plus 1. CA4 is equals to 3, means C3 plus 1. C3 is equals to 0 plus 1, means 1. Means CA4 is equals to 3, C3. So C3 is equals to 1. So this will become equals to 1, right? C3 would become equals to 1. Now finally for j equals to 5, CA5 is equals to CA5 plus 1. A5 is equals to 1. So A5 C1 plus 1, or A5 is equal to C1. So C1 is equals to 2. C1 is equal to 2. 2 plus 1 equals to 3. So now, so C1 value would become equals to, instead in place of 2, it will become 3, right? This is not a very complicated step. This is very easy step. What we are doing here, we are just counting the frequency of each distinct element in the unsorted array. Here in this unsorted array, the frequency of 1 is 3, 1, 2 and 3. The frequency of 2 is 2 and frequency of 3 is equals to 1. So C is simply the frequency of each distinct element, and this can be calculated just by using the formula Caj equals to Caj plus 1. So I think that it is clear to you. Now what we will do, the next step is for for our next for loop is for I is equals to 0 to k. What we do, we calculate the cumulative frequency using the value Ci equals to Ci plus Ci minus 1. This is the simple formula. So to calculate the cumulative frequency, Ci equals to Ci plus minus 1. So simply you can do this with help of this Ci. So this is the frequency 0. So 0 plus 3, 3, 3 plus 2, 5, 5 plus 1, 6. So cumulative frequency, what does cumulative frequency represent? This represents that there are 0 elements which are less than 0. Cumulative frequency 1 is equal to 3. It means there are 3 numbers which are either less than 1 or equals to 1. Cumulative frequency 2 is equals to 5. It means there are 5 number which are either equals to 1, equals to 2 or less than 2, and cumulative frequency 3 is equal to 6 means there are 6 element which cumulative frequency is either less than 6 or equal to 6. Okay, so this is the very easy step. And now the finally what we will do, we shall construct array of size equals to the unsorted array A. It means the length of the unsorted array is equals to 6. There are 6 elements from 0 to 5. So we shall construct another unsorted array, and in this way we need an extra array to sort the data. So this is not an in-place sorting technique. So here what we do, we shall construct another unsorted array B, okay, which length is equals to the length of the unsorted array. And to fill the array, what we need the formula, I am rubbing this page, this value is okay. We need the formula B C A J is equals to AJ, right? And after that the important step is CAJ is equals to CAJ minus 1. What is the significance of CAJ equals to CAJ minus 1? Every time we count a number and use it, then we have to deduct that value from the cumulative frequency, because this is being used in the equation. So if you will leave this step, then the result will not be correct. So remember that the second, you may directly calculate the value from BCAJ, but if you do not deduct the value from the cumulative frequency, then you will get the wrong result after 1 or 2 iterations. So this is the very important. The second step is equally important, and you must go through both of these steps when you process these elements one by one. Okay, so for j equals to 0, BC A0 is equals to A0, means here A0 is equals to 1, and this is equal to BC. A0 is equal to 1, so BC1, C1 is equals to 3, so C1 is equals to 3. Okay, C1 is equals to 3 is equal to 1. Okay, right? A0 is equals to 1 and C1 is equal to 3. So B3 is equals to here. So B3 in here, what we are doing, BCAJ is equal to CAJ minus 1 is equal to CAJ minus 1. Here once what I have written in your book is that the formula was CAJ equal to CAJ minus 1, I think. CAJ minus 1. Right. Okay, so A is 1. So here, while calculating the value, we initialize the value from 1. So J1, for J equals to 1, A1, 1 second, A1 is equals to BCAJ. So in this cumulative frequency, indexing will be like that. We will not consider this element 0, because since there are 3 distinct elements, we do not consider that. So is equals to C1. C1 is equal to 3. Okay. So just a second. Right. So C3 is equals to 1. Now after that, for J is equals to 0, right? Now next element for j equals to 1, b c a 1 is equals to a 1, a1 is equals to 2, and b c a 2 is equals to a2 is equals to 2, a2 is equals to 2, so b c a1 is equals to a1 is equals to 2, so c2, this is c2, and c2 is equals to 2, so b2 is equals to 2. Just a second. Pause.